Okay everyone, we're starting a new chapter on polynomials, and today we're going to define polynomials. In fact, we're going to define a lot of words. I'm sorry, this isn't probably the most exciting video. I'm going to try to fly through a lot of these terms, but they are super important because we use these terms all the time, so you kind of need to know what I'm referring to. Now some of them you're going to know already and some you won't. So the first one, for example, should be reviewed for you. A variable. A variable is a letter whose value is an unknown number. So, for example, probably the most common letters that are used for unknowns are things like X and Y and Z. Other popular ones are M and N, but really it could be anything. You can use any letter you want. Alright, a term. A term is a number, or the product of a number and variable, which may be raised to a power. That sounds kind of confusing, so let's give you some examples for that. The first thing it says is that it could be a number. So for example, 7. There's a term right there. The second thing it says is the product of a number and variable, or variables. So let's do the product. That means multiplying, right? Let's do the product of 2 and a variable. Let's pick y. 2 times y, or a faster way of saying that, 2y. So that's also a term. And the third thing it says here, you could also raise one of the variables to a power, or more than one of them to a power. So for example, let's throw a -3, there's a number. Let's put a couple variables, how about x and y? And let's raise our y to the second power and let's raise our x to the second power and our y to the fifth power. That's an example of term. All these things that look like this, these are all terms. Alright, in a term there's something called a coefficient. The coefficient is the number in front of a variable. So if I had a term like 5x, what is the coefficient? Well, the number in front is 5. The coefficient is just 5. What about if I had -2y? What's the coefficient? The coefficient is -2. Maybe I should circle. -2. In this case, it's 5 is the coefficient. How about this? What if I had m? What's the coefficient in that case? I don't see a number in front. Well, how many m's is that? That's 1m. m is the same as 1m, and that's what the coefficient is in this case. If you just have a letter, a variable, the coefficient is 1. Okay, a constant. A constant is a standalone number with no variable attached. So in a second here, we're going to start talking about complicated polynomials, things like 3x squared plus 2x minus 4. And it says a constant is the number that has no variable attached to it. Well, it couldn't be this because there's a variable right there. And it couldn't be this because there's a variable right there. But look at that 4. It has no variable attached to it. But that's the constant. But be careful. The constant is actually not 4 here. The constant is -4. You always take the sign in front. Now I know that's confusing. You're probably like, wait a minute, I thought that was a takeaway 4. Are you saying it's a -4? You have to get used to the idea that a takeaway 4, a -4, is the same as plus -4, right? M takeaway 4 is the same as m plus -4. So if you have m minus 4, the constant is -4. And this is more obvious here, it's -4. It's less obvious here, it's -4. Exponent, you know this one. This is the power to which a number or variable is raised. So it could be a number raised to a certain power. I don't know, I'll put a 3 there. It could be a variable. How about an m raised to, I don't know, I'll put a 5 here. Right? This is an exponent, the little number there. This is an exponent, the little number there. How about this one? What's the exponent? Again, I don't see an exponent. If you don't see the exponent is 1. So there is an exponent there as well, an invisible one. Okay, now we come to 3 terms, monomial, binomial, trinomial, and actually a 4th term, which is a polynomial. So the monomial definition is a little complicated. It's an expression of the type a times x to the n, where a is a real number and n is a whole number. Let's not stress out about that too much. Let's give some examples to help you out. An example would be something like 2x cubed. Do you see that kind of fits this format? Because the a is 2 and the n is 3. But it doesn't just have to be x, it could be any letter at all. So I could have something like 3m. How about that? Yeah, a is 3, the x have been replaced with an m here. What about the n? Where's the exponent? Well, you know what the exponent is. There'd be a 1 there, right? How about y to the 4th? Yeah, instead of having our x, we have a y. Instead of our n is our 4. What about the a? Where's the a? Again, you could put a 1 there, so that also fits the format. All these things are monomials. Even something like this. I know it doesn't seem to really fit the format here, but here's the key. As long as you don't see a plus or a minus sign, it's monomials. Mono means one. This is one term. This is one term, one term, one term. As long as there's only one term, it's a monomial. Guess how many terms there'll be if it's a binomial? Bi means 2. There'll be 2 terms. It's a polynomial of 2 terms. Monomials are also polynomials when they have 1 term. A binomial is a polynomial with 2 terms. So something like 4x squared, there's 1 term, plus 3x. As soon as you see a plus, you know there's another term, and so you have 2 terms. How about 5m squared n, that's all 1 term, minus mn cubed p. Yeah, there's only 1 minus in there, so that separates our 2 terms. Pluses and minuses separate terms. Trinomial, tri means 3. It's a polynomial of 3 terms. So something like 4x squared, there's a term, plus, oh, must be getting a second term, 2xy, there's another term, minus, oh, there's a minus, must be another term, y. So there's 3 terms there. Polynomial. A polynomial is a monomial, a binomial, a trinomial, or even more terms. So there's all sorts of different polynomials, and 3 of them have special names. These 3 have special names, but they're all polynomials, right? Monomials are polynomials that only have 1 term. Binomials are polynomials that have 2 terms. Trinomials are polynomials with 3 terms. You also have polynomials that have more than 3 terms. How about something like 3x cubed plus 2x squared minus 4x minus 7. 1, 2, 3, 4. This is a 4-term polynomial, it's called. If there was 19 terms, it would be a 19-term polynomial. The next term is the hardest one, I think, of the whole lesson. It's the degree of a term and the degree of a polynomial. So to get the degree of a term, it's equal to the sum of the exponents on all its variables. So for example, if we had 5x squared y cubed, we just look at the variables, the x and the y, and we add together the exponents. So there's a 2 here, there's a 3 here. So to get the degree, we would go 2 plus 3, which equals 5. That is your degree right there. How about if it was x, y squared, z to the 5th? We look at all 3 of our letters and we add together the exponents. We add together a 5, a 2, and don't forget, there's a 1 right there. So we would end up with 1 plus 2 plus 5, which equals 8. Okay, one more. What if we had 4 squared x cubed? I know what you're saying. You're saying 5, right? Wrong. The answer is 3. How come? Because it's all the exponents on the variables. 4 is not a variable. So you just look at the exponents on the variables. This isn't common. I mean, why wouldn't you just put 16 here instead of 4 squared? Here's the one that gets people all messed up, the degree of a polynomial. So remember, a polynomial can be made up of more than 1 term. The degree of a polynomial is equal to the term with the highest degree. Definitely need an example here. 5x squared plus 3xy minus 6y to the 5th. How many terms do we have here? Remember, pluses and minuses separate them. So we have 1 term here, we have a 2nd term here, and we have a 3rd term here, which means we have a trinomial. Now, what's the degree of just this first term here? Remember, you just look at the exponents on the variable, and it's just 2. What's the degree of this one here? Remember, there's a 1 there and a 1 there. We add them together, we get 2. What's the degree in this one? We just have that 5. It's the only variable has a 5, so the degree is 5. So what's the total degree of the whole thing? I know what you want to do. 2 plus 2 plus 5. But look, it's equal to the term with the highest degree. Which term has the highest degree? This one here is the highest. 5 is the biggest. And that means the whole polynomial has a degree of 5. Okay, the leading term is the term with the highest degree. It's called leading because you tend to write it with the leading term first, but you don't have to. So I'll give you a confusing example here. If you had 5x squared minus 3x cubed plus y, you have three terms here, right? Which one's the leading term? Now you might say 5x squared because it's leading, it's the first one. No, it's the one with the highest degree, and the one with the highest degree is this one. So the leading term is negative, remember we always take the sign in front, negative 3x cubed. Okay, how about the leading coefficient? Well, that's the coefficient in the leading term. So in the example I just gave you, which I'll rewrite here, we already said the leading term was the negative 3x cubed. What's the coefficient of that leading term? It is the negative 3. That's the leading coefficient. Remember, the coefficient is the number in front of a variable. Okay, how we usually write polynomials is not the way it's written here. We usually do it in descending order of powers. So we go from the term with the highest degree to the term with the lowest degree. So let me rewrite this thing that we just had up here. Let me write it in the correct order. You'd actually write the leading term first. So remember, the leading term includes that negative. So you would have negative 3x cubed. The next highest one is the x squared. Well, what sign should I put in front of that? If you don't see them, it's a plus. So plus 5x squared, and then plus y. That's the correct order right there. The other rule that you try to follow if you can is alphabetic order. I don't think I need to give you a definition for that one. But these can be very difficult to understand exactly which order to do. So if we had this xy plus y squared minus x squared, look, they all have the same degree. The degree of this is 2, because 1 plus 1 is 2. The degree of this is 2, and the degree of this is 2. You have three terms, and they all have the same degree. So descending order of powers, well, I don't know what to do. So what you want to do in this case is try to do it in alphabetical order. So first of all, pick the term that only has x's in it. That's this one. So you'd have negative x squared. Then pick the one that has at least one x in it, so that'd be plus xy. And then do the one that has no x's in it, only has y's, so that'd be plus y squared. Now, I've picked examples that are pretty obvious, but sometimes the descending order of power and the alphabetic order kind of contradict each other, and we'll talk about that in class. It can be a little bit complicated, and you know what? There's some leeway. All right, we're going to fill in this table. Again, I'm going to try to do this pretty fast. So I'm going to do just terms first. Remember, terms are separated by plus or minus signs. So I see 1, 2 terms here. There's only one term here, right? I know there's a minus sign, but there's nothing in front of it, so it's just one term. I see 1, 2, 3 terms. I got a plus and a minus that separates 3 terms. I see 1, 2, 3, 4 terms in this one, and I see just one term in this one. I would recommend you stop the video and actually try filling this in. That'd be really smart. Name. Well, if there's 2 terms, it's a binomial. 1 term is a monomial. 3 terms is a trinomial. 4 terms is a 4-term polynomial. And 1 we already said was a monomial. Okay, the correct order. Here's one that contradicts. Do you go by descending order and go degree 2 and then degree 1? Or do you go by alphabetical and put x before y? Let's say either one's fine. So I'm not going to answer this one. Correct order when it's a monomial? Well, there is no order. There's just one way of doing it. Okay, here's one that there definitely is a correct order. You start with the one with the highest degree. Well, that'd be your x squared. So you need to have 5x squared. Then you put the one that has degree 1. That's the negative 2x. And then you put the one right here, the 9, which would be plus 9. This one as well, you got 3 terms with the same degree. I guess you do alphabetical, so you'd start with your r's, rs, negative 5rs. Then you'd go to your xy, because at least it has an x in it, so plus 3xy. Sorry, this is so small. Then you've got your y squared. And finally you got your, minus 2. And finally you have your minus 2. Last one, it's just a monomial. There's no correct order for it. It's just the way it is. Leading term? Well, it depends. If you put it in this order, your leading term is 5y squared. And maybe I'll write that down. If you put it the other way, then your leading term, if you put it like this, negative 3x plus 5y squared, your leading term would be negative 3x. Okay, this one leading term, well, there only is one term, so it has to be negative 45xy squared z cubed. This one, the leading term, once we have an order, it's easy. You just pick it out there. It's 5x squared. Leading term of this one, just pick it out. We have negative 5rs. And leading term here, well, we only have one term. It's negative 4. Leading coefficient. What's the coefficient of leading term? 5. Or if you did this one, negative 3. Leading coefficient here is negative 45. Leading coefficient of this is 5. Leading coefficient of this is negative 5. And leading coefficient here, well, there is no variable. Remember, the coefficient's in front of a variable, and there is no variable, so I would say none on this one. Degree. Okay, in the first one here, we have a degree of 2, and the second term here, we have a degree of 1. Now pick the biggest, which is 2. Degree here, we've got 1 plus 2 plus 3, which equals 6. Degree here, this is a degree of 0 because there's no exponent. This is degree of 2 and this is degree of 1. Biggest is 2. This is degree of 2, this is degree of 0, there's no exponent. This is degree of 2 and this is also degree of 2 because you have 1 plus 1 there, which is 2. So the biggest is 2. Don't add them all up, just pick the biggest one. And this bottom one has no exponent, so you shouldn't put none here. If you're really precise about it, it has a degree of 0. Variables, you're just writing down whatever letters you see. I see an X and I see a Y. Might as well put them in alphabetical order. I see an X, Y, and a Z. I see an X and that's it. I see an X, Y, and also RS, so I guess I have R, S, X, and Y. And variables here, there is none. Okay, list all the coefficients, not just the leading one, but all of them. Well, here I have a 5 and also a negative 3. And this one I have a negative 45 and that's it. Okay, this one I definitely have a negative 2 and a 5. And then I have a controversial 9. I don't like calling this a coefficient because a coefficient's in front of a variable. So I say you don't count that. Your book actually includes that, which strikes me as weird. Same with this. Your book would put negative 4 where it says none here. They count that. But to me, it's much more a constant, right? A constant's a number with no variable. To me, it's much more a constant than it is coefficient. So I guess I can't mark it wrong. Your book does it this way, but I really don't think that 9 and this negative 4 is a coefficient. I think they're constants. Okay, same with this one. I'm going to say 3, negative 5, and don't forget the 1 in front of that y, right? There's a 1 right there. So I'm going to say 3, 1, and negative 5. Personally, I would not put the negative 2 because I think it's a constant. But your book would put the negative 2, which I don't like. Your book puts both. They put it as a coefficient and a constant. I don't like that. So again, to me that's not a coefficient, but you could be like the book if you want to put negative 4 here. You could be like the book and put a negative 2 here. You could be like the book and put a 9 there. Okay, constant. These are numbers all by themselves. There isn't one here. But you could actually put one. You could put plus 0. So 0 is the constant. You shouldn't put nothing or none. You could put 0 for that. Constant in this one, again, I don't see one, so 0. Constant in this one, 9. 9 does not have a variable attached to it. Constant in this one, negative 2. Make sure you take the sign in front of it. And constant in this one, negative 4 is a constant. It has no variable attached to it. Wow, we did it. That was a lot of stuff to take in one day. Good luck with this, and don't be worried if you get a little confused at first. You'll start hearing these words a lot, and you'll get it. Okay, take care. Bye.